Hello, folks. We're going to be going over two big topics today. We're going to look at calculating elasticity of demand and then the basic qualitative understanding of income elasticity. So in general, elasticity of demand is equal to the percent change in quantity demanded compared to a percent change in price. So if we're looking at the elasticity of apples versus oranges, and we're looking at a 10-cent change in price, well, a 10-cent change in price for bananas is far bigger than a 10-cent change in price for apples, because bananas cost about 50 cents a pound, and apples cost between 80 cents and $3 a pound. So 10 cents is a big difference in banana markets, or in apple markets, Honeycrisp apples changing 10 cents doesn't mean much. And that's why we look at percentages, so that we are making an apples to apples or oranges to oranges comparison. Now, when we're looking at a demand curve, we would say that demand curve 1 is more elastic than demand curve 2. However, because of the nature of percentages and the way that elasticity works, each demand curve, oops, that's terrible, has two sections. They have an elastic portion and an inelastic portion. But keep in mind, this demand curve is still more elastic overall than a demand curve that has a far steeper slope. Now, the reason why at high prices it's elastic is because the same change in price in absolute terms, think about the change in price in terms of percentage terms. This is much lower than it is down here. So if my formula, elasticity of demand, is percent change in quantity over percent change in price, when this is low, that means that this number is going to be low, and my corresponding change in quantity, when quantities are low, is going to be high. So we're just looking at, just by the mere fact that when prices are high, price changes as a percentage term are going to be low, but since the prices are high, the quantities are going to be low, and therefore the percentage changes are going to be high. The other reason that I think you should grasp onto first and then see the quantitative nature of elasticity of demand is that when prices of a good are high, there are more substitutes. So if we think about this as airfare, when prices are high, we say that demand is elastic. There's a big change in response to price changes. And think about why that might be. Let's just pick a location at random. Let's say, I don't know, St. Louis, buying a plane ticket to St. Louis. And the plane tickets are expensive. They're $600, $700, $800. What's a great substitute for flying? Driving, taking the bus. If the price is much lower, $100 or $150, now is there a good substitute? There isn't, because you can't drive there for that little money. You can't get there that quickly. You can't be compensated for your time. So we can see that when prices are high, other substitutes become more realistic, because if you're willing to pay a high price for an airline ticket, you have this money that could be used for a substitute good. Right? So before we get into calculation, I know you read, so I'm just reminding you, if elasticity of demand is greater than 1, we say that it's elastic. If elasticity of demand is less than 1, we say that it is inelastic. And remember, we're talking about absolute values. Because demand and the law of demand is that price and quantity are inversely related, if we're looking at percent change in quantity demanded compared to percent change in price, when this one goes up, this one always goes down, and the other way around. So it's always negative. So when we say elasticity of demand is 3, we really mean that it's negative 3. So if you drop the sign, it's not a big deal. Now, by the way, when we talk about income elasticity later on, then all of a sudden the sign makes a difference. But for now, it's absolute values and we don't worry about the sign. When elasticity of demand is greater than 1, that simply means that the numerator is bigger than the denominator. It means the price changed, the quantity demanded changed more. So when it's greater than 1, that's saying it's elastic, it's responsive. When it's less than 1, then my fraction is the typical fraction we think of, and the numerator is smaller than the denominator. Hey, the price changed, but the quantity didn't change as much. It's inelastic. Now, if we're thinking about a continuum from 0 to a really big number, sure, we're saying that between 0 and 1, goods are inelastic, and if they're greater than 1, we're saying that it's elastic. That doesn't mean that this is some hard and fast dividing line between, or that something magical changes. If we're saying that elasticity of airfare is 0.95 and elasticity of bus travel is 1.1, they're both not really elastic or inelastic. They're both right around 1. So it's continual. It is a continuous change. It's not like something discrete happens at once. So just keep that in mind. All right. Let's assume that demand for airline tickets is equal to 2,000 minus 3QD. Good. And let's ask the question, what is elasticity of demand between 200 and $300? So now I'm not asking about an elasticity at a specific point. I'm asking about elasticity over a range. So I need to find the different quantities demanded at $200 and $300. So at $200, my quantity is 600. Okay. And at $300, my quantity is 567, I believe. $566 and 2/3. Yep. So to find the elasticity between these two, I need to find my percent change in quantity and then my percent change in price and just compare the two. So let's start off with percent change in price because this one is really the easiest. Price 1 minus price 2, 200 minus 300 over the average of the two. And we're saying the average because I'm comparing a $100 price movement between $200 and $300, not $100 compared to $200 or $100 compared to $300. See my example about markup and margin from yesterday. So the average is 250 or 100 over 250, which I believe is 0.4. 100 divided by 250 is 0.4. And of course, that's negative 0.4. So my percent change in price is negative 40%. My percent change in quantity is now Q1 minus Q2, 600 minus 566 and 2/3, divided by the average of those two. Which is 583 1/3. So 33 1/3 divided by 583 1/3 is only 5.7%. So my elasticity is equal to this number because the percentages cancel. So that divided by 0.4 is my elasticity of demand as a decimal is negative 0.142857. So one way to interpret this is to make it into a fraction over 1. A 1% change in price over this range has an approximate 0.148% change in quantity, a very small amount. Between $200 and $300, we would say that elasticity of demand for this product is very inelastic. And think about why that is. $2,000 is where this demand curve starts. When we're talking about elasticity between $200 and $300, that's a really low price. So for something that people are willing to pay at some level to $2,000, $250, $300 is not much. It's very inelastic. Okay. Now, the book says, hey, you know what? You don't have to use that arc elasticity formula. You can use this formula. Elasticity of demand is equal to price over quantity times change in Q over change in P. Use this formula and you can get specific point elasticities. This is the same formula as the arc formula, and I'm going to prove that in just a second. But before we do that, so let's remember our elasticity in this range was 0.14857, something like that. So I'm just going to circle that and remember. Let's find our elasticity of demand at $250, right in between. So if my price is $250, negative 1750 is equal to negative 3Q. My quantity should be equal to 575, I think. 1750 divided by 3. Oops. Nope, 583. 583.33 or 583 1/3. Okay. So when my price is $250, so just plug into this formula, divided by 583 1/3 times change in Q over change in P. That's slope, but be careful. We know what slope is. Slope of this demand curve is negative 3, but negative 3 is not change in Q over change in P. It's change in P over change in Q. So we have to use the reciprocal of that, or times negative 1 over 3. So my elasticity is equal to 250 over 583 1/3 times 3, which is 1750. And if I take 250 divided by 1750, I get 0.142857, which is exactly the answer that we got when we were using the arc formula over a range that was equally above and equally below the price that we've picked right here. So let's think about how this really is the same thing. And I'm doing this off the cuff, so bear with me. All right, so our old formula, elasticity of demand, is percent change in quantity demanded divided by percent change in price is really equal to Q1 minus Q2 divided by the average of those quantities divided by P1 minus P2 divided by the average of those. And let's think about what these terms really are. Now, because we're using this range over an equal amount above and below, QA is really just Q. So we can just leave it Q. And Q1 minus Q2 is really change in Q, and P1 minus P2 is really change in P. So I can make this change in Q over Q divided by change in P over P. And this is not going to pretend like we have more marker board. This change in Q over Q divided by that is the same as multiplying by the reciprocal, P over change in P. Start looking at what we have. The top is P times change in Q, and the bottom is Q times change in P, which is what we have. We've proven that they're the same thing. What we're really doing is we're unpacking or understanding the concept of a limit. So whether you use the point elasticity formula or you use the arc elasticity formula, you'll get the same answer. So long as we're saying, what's elasticity at $250? Pick prices above and below by the same amount, and you'll get the same answer as we just saw. Okay, now would be a good time to pause me because we're going to move on to income elasticity. Income elasticity is equal to percent change in quantity, just like we saw before, compared to a percent change in income. Now, before I go on any further, goods are always at the mercy of the law of demand. There are no goods that when the price goes down, the quantity goes down as well, ceteris paribus. Okay? There's some confusion about something called inferior goods. They don't defy the law of demand. They have something to do with income. We're not talking about price anymore, we're talking about income. We're assuming that the prices of these goods are changing, or that they're staying the same, but your income is changing. If income elasticity, if it's greater than 1, we say that the good is a luxury good. If this ratio is greater than 0 but less than 1, we say it's a normal good. And if it is less than 0 or negative, we say that it is an inferior good. So let's start off with luxury goods and see what that means. If this number is greater than 1, that means the numerator is bigger than the denominator. So if your income increases by 10%, and your consumption of a good increases by 15%, income elasticity is equal to 1.5, and we say the good is a luxury good. This wouldn't be a really strong luxury good, but it would be a luxury good nonetheless. So for Mother's Day, I sent my parents a prime rib dinner from a restaurant in Omaha called Timber. It's near Omaha West Side. If you ever have a chance to go there, it's delicious. Let's say that I got a 10% raise. It's not that expensive. You can get meals for $15 there, but you can spend 30 or 40 pretty easily. And I'd say we go to Timber 2 times a year. My birthday and my wife's birthday, or her birthday and some other event. If I got a 10% raise, and now we go to Timber 4 times a year, now I have a 100% increase compared to a 10% raise, and my income elasticity is 10. That would be clearly a luxury good. If a small change in my income caused a large change in my demand for a good, it's a luxury good. Okay? Now the flip side of that, we're going to leave inferior goods for last, or normal goods for last, is inferior goods. Let's say that, again, we're just going to think positively. I have a 10% raise, and my Taco Bell consumption falls by half. Income elasticity is negative 0.5, meaning that it is an inferior good. And the relationship that the good shows to income is an inverse relationship, meaning the more money I make, the less I want something. What's happening in this case is my demand for Taco Bell as my income rises is falling. Notice the law of demand still holds. My demand falls, and let's say I have this 10% raise, I'm eating Taco Bell half as much as I previously was, and now Taco Bell becomes less expensive. Well, I'm going to buy more Taco Bell. I still follow the law of demand. When I go to Taco Bell, even though it's less, I'll buy more of it. So the law of demand still is holding, just the way that the demand curve is shifting with changes in income is the opposite to what is happening to your income. Okay? A normal good is one that you have, stick with my 10% raise example. I get a 10% raise and my consumption of ketchup or my purchases of ketchup increase by 5%. That's barely any. I get a 10% raise, that's some substantial amount of money. I increase the amount of ketchup buying that I do by some small amount, 5%. How does that happen? Well, maybe I buy smaller bottles so they fit better in the refrigerator, or maybe I don't rinse out the bottle at the end of the day. Maybe I allow my kids to put ketchup on their plate themselves and they waste a lot, something like that. It's hard to imagine how that happens, but there's no way that me getting a raise lowers my consumption of ketchup. Ketchup will never be an inferior good for me, anyway. Okay, so if a good is normal, it follows the direction of your change in income. It's just not a strong relationship. Okay. The tricky part about income elasticity is that things aren't always inferior, normal, luxury. So here you can see hanging on the wall there is a small flat screen TV, 24-inch plasma TV. I bought it over 10 years ago, probably 12 or 13 years ago. I think it was $400 for a refurbished 24-inch plasma TV. At the time, that was a luxury good to me. A 24-inch LCD TV is really probably not a luxury good anymore. It's just a normal good. It becomes a normal good because its price has fallen. It's no longer really expensive. It's not special, and our incomes have all risen. Even more, it's not really complex, it's just something to think about. Different goods are different things to different people. So in my example of inferior, normal, and luxury goods, I might say Taco Bell, Chipotle, Qdoba, same place to me, and Rick Bayless. So if you don't know what this is, Taco Bell, cheap Mexican food, Chipotle, less cheap Mexican food. Rick Bayless is a world-renowned Mexican chef, has a restaurant in Chicago. It's very, very expensive Mexican food. He's also related to an obnoxious ESPN reporter named Skip Bayless. Hard to believe. To me, this is probably close to accurate. Even though I really like Taco Bell, I know it's pretty bad for you. It makes me feel awful the next day. I only buy Taco Bell because I have to. Chipotle is more of a normal good. You know, it's not something that, hey, we celebrate and go eat at Chipotle, but Rick Bayless's restaurant might be. Now, for you, Taco Bell might be a normal good. If you're a normal college student and you have very, very little income and little cash, it's just a normal good. And Chipotle might be a luxury good, and Rick Bayless is obviously a luxury good as well. And so it's unique to individuals and unique over time, or it can change over time as well. That's just part of the critical thinking of this class, and something that we'll talk about later this afternoon. All right, hopefully you get a chance to watch this, and we'll see you at 1 o'clock.